Hi students, welcome to Sunil's tutorial. I'm Sunil Mewani and today we'll be doing atomic structure. Now, last lecture we had seen what are orbitals. Today we'll see something new which is called as Avbos principle. Right? Avbos principle tells you how electrons are filled in their atomic orbitals. Right? Now, Avbos principle says, guys start writing with me, electrons are added progressively. Electrons are added progressively with the orbital of lowest energy to various other orbitals in the order of increasing energy. Right? That means when I have to fill electrons into orbitals, then you have to fill electrons in the increasing order of energy. The orbital that has more energy will get electrons later. So it goes from lower to higher. Right? Now, Avbos principle is divided into two parts. One is called as energy sequence rule 1 and the other is called as energy sequence rule 2. Avbos principle has two further classification. One is called as energy sequence rule 1. Energy sequence rule 1 says that if the sum of n plus 1, I hope you all remember what is n. N is principal quantum number. If the sum of n plus 1 is different for two orbitals, then the orbital for which n plus 1 is lower will get filled first. If n plus 1, I'll just show you this with an example first. Let me write the rules. If n plus 1 value is different plus L. Value is different for two orbitals. Then the orbital with lower n plus L gets filled first. Right? I'll show you all this with a diagram. First, let me just write the rules down, guys. Then you have energy sequence rule 2. Energy sequence rule 2 says that if the sum of n plus L is same for two orbitals, then the orbital which has lower value of n will get filled first. If n plus L is same for two orbitals, then the orbital with lower n gets filled first. Lower n gets filled first. Right? Now see, how do I do this? I'll explain this rule to you with the help of a diagram. See, this is 1s, 2s, 3s, 4s, 5s, 6s, 2p, 3p, 4p, 5p, 6p, right? Then you have 3d, 4d, 5d, 6d, 4f, 5f, 6f, right? Now, the orbitals are going to get filled this way. See, first the 1s orbital will get filled. Then you will have diagonally 2s orbital will get filled. Then you will have 2p. Then you will have 3s. Then this will go to 3p. After 3p, 4s will get filled first. Then you will have 3d that will get filled. 4p, 5s, right? That is the order in which orbitals will get filled. So you will have 3d, then you will have 4p, 5s, then you will have, you've done this, so in that case then you will have this number. You have you will have 4d, 5p, 6s and so on. That's how you will have the orbitals filled. Then you will have 4f, 5d, 6p, 5f, 6f and so on. Right, do you get this? That is what is Apgoe's principle. Apgoe's principle says that the lower energy level gets filled first and then the higher energy level gets filled. If the energy level is same for two orbitals, then the value which has n plus l lower will get filled first. That is what is Apgoe's principle. So this is the order in which electrons have to be filled. I will show you the, we'll do this example. But do you understand what is Apgoe's principle? In simple language, those orbits will get filled first which have lower energy. Orbitals with lower energy will get filled first and orbitals with higher energy will get filled later. That is what is Apgoe's principle. Right? Next, you have another rule called as Pauli's exclusion principle. Now, Pauli's exclusion principle says that it is impossible for any two electrons to have the same set of all four quantum numbers. It is impossible for any two electrons to have same set of all four quantum numbers. That means each electron has a particular quantum number and that electron, no other electron will have those same set of all four quantum numbers. Right? That is what is Pauli's exclusion principle. Next, you have Houns's rule of maximum multiplicity. See, we had said that orbits are divided into orbitals, right? Now, let's see this. For example, let's consider, say, carbon. Carbon, say, atomic number is 6, right? Now, the general electronic configuration, that is your electronic configuration as per Rutherford's rule, should be 2, 4. First orbit will take 2 electrons, second orbit will take 4 electrons. This first orbit is further divided into first 1s orbital. The second orbit is divided into 2s and 2p orbital. This is 1s, 2s and 2p. The 2p orbital is oriented in 3 directions, x, y and z. Okay? See how the electrons get filled. Now we had said that electrons have something called as spin quantum number. There are some electrons that rotate clockwise, there are some electrons that rotate anti-clockwise. Right? So, first 1s clockwise electron will get filled. Then in the 1s orbital anti-clockwise electron will get filled. Right? Then in the 2s clockwise orbital will get filled. Right? Then you will have in the 2s you will have anti-clockwise electrons getting filled. So 4 electrons are gone out of 6. Then the remaining 2 electrons have to be clockwise, which are going to get filled in 2px and 2py orbital. Fine? So in simple language, what is Houns's maximum multiplicity rule? He says that all the clockwise electrons will get filled first and then the anti-clockwise electrons will get filled. Right? For example, if I had, say, oxygen. Let's see for oxygen. If I consider oxygen, that will give you a fairer idea of how the electrons get filled. Oxygen atomic number is 8, right? Electronic configuration is 2,6. So this is 1s, 2s, 2p. 1s, 2s, 2p. 2p is further divided into x-axis, y-axis and z-axis. Clockwise, anti-clockwise. Before I move to the next orbital, I should have both clock and anti-clockwise. Clockwise, anti-clockwise. I'm moving from s orbital to p orbital. I cannot go to p orbital till the time I don't have both. 4 electrons are gone. Total there are 8 electrons, right? 1, 2, 3. First all the clockwise will get filled and then you will have one anti-clockwise getting filled. So electrons get filled in one direction first before they get filled in the other direction. That is what is Houns's maximum multiplicity rule, right? Now I'll write the rule down. Write the law down, guys. The law says that when several orbitals of same energy level are available, then the electron first fill all orbitals singly with parallel spin and then pairing of electrons takes place. That is what is Houns's maximum multiplicity rule. So Houns's maximum multiplicity rule says that electrons will get filled in a particular orbital in one direction first before they get filled in the other direction. Now let us see how do you write the electronic configuration as per Bohr's atomic theory. We are going to write electronic configuration of the first 30 elements, right? Let's see this atomic number, symbol and electronic configuration. Right? Let's consider atomic number 1, hydrogen. The symbol is H. Right? 1 electron only, it will get filled in the first orbit. So your principal quantum number will be 1. First orbit has only one orbital, S1. 1s1. That is how you write the electronic configuration. Each orbit is further divided into orbital s, p, d, f. Right? S orbital can take a maximum of 2 electrons, p can take 6 electrons, d can take 10 electrons and f can take 14 electrons. Remember this and things should be easy. Let's consider helium. Helium has 2 electrons. What did I tell you? S orbital can take 2 electrons. So where will both the electrons go? They will go in the s orbital, first orbit. Till the time our orbit and its orbital does not get filled, you cannot move ahead. So in the first orbit, s orbital will take 2 electrons. Right? Next, lithium. Right? 3 electrons. Now its electronic configuration as per Rutherford's theory, guys, remember is 2-1. Right? Its electronic configuration as per Rutherford's theory is 2-1. The first orbit can take a maximum of 2 electrons. First orbit, both the electrons will go in s orbital. 2 electrons are gone. Right? First orbit is gone, then you will have second orbit. Second orbit will again start with s orbital only. So s orbital and it will take 1 electron. So the 3 electrons are going to be filled this way. 1s1, 1s2, 2s1. 3 electrons. First orbit can take 2 electrons, that will go in the s orbital. First orbit can take 2 electrons, both the electrons are in the s orbital. Second orbit, you always start with the s orbital. Till the time s orbital does not get filled, you don't go to the p orbital. Right? Next, beryllium. Four electrons. Guys, try writing this on your own, then I'll write it on the board. Right? This is going to be first orbit will take 2 electrons. So 1s2. There are 2 more electrons remaining. We know that s orbital can take a maximum of 2 electrons. So both those electrons will go in the s orbital. So it will be 1s2, 2s2. Right? Next, boron. 5. Try writing this on your own, guys. 1s2. First orbit will take 2 electrons, both will go in the s orbital. Second orbit will take 2 electrons in the s orbital. Right? 4 are gone. How much is remaining? 1 more is remaining. That will go in the p orbital. After s orbital gets filled, the next is p orbital. S orbital can take a maximum of 2 electrons. P orbital can take a maximum of 6 electrons. Now till the time you don't fill 6 electrons in the p orbital, you cannot move ahead. Okay? Guys, try writing this. Carbon. One s 2s2. First orbit can take 2 electrons. Both of them will go in the s orbital. Second orbit, the first 2 electrons will go in s orbital. 4 electrons are gone. 2 more electrons remaining, that will be in the p orbital. 2p2. 1s2, 2s2, 2p2. Right? Next, nitrogen. Right? Nitrogen. Guys, please try writing for nitrogen. Try this on your own. 7 electrons. See the previous one and try writing it on your own. How will you do this? This will be 1s2, 2s2, 2p3. First orbit can take 2 electrons, both the electrons will go in the s orbital. Second orbit, s orbital will take 2 electrons. So 4 electrons are gone, 3 remaining, 3 of them will go in p, because p has a capacity of 6. So till the time p is not filled, I cannot move ahead. Next, after nitrogen you have O, which is oxygen. Right? Oxygen. Guys, try writing oxygen on your own. 1s2, 2s2, 2p4. Right? 1s2. First orbit can take 2 electrons. Both the electrons will go in the s orbital. Second orbit, s orbital will take 2 electrons. So 4 are gone. Remaining 4 will go in the p orbital. Right? After oxygen you have fluorine. One s2, 2s2, 2p5. Done, guys. After fluorine, you have neon. Neon, please write the configuration for neon. 1s2, 2s2, 2p6. First orbit can take 2 electrons. Both the electrons will be in the s orbital. Second orbit has to start with the s orbital. S orbital will take 2 electrons. So out of 10, 4 are gone. 6 will go in p. P has a maximum capacity of 6. Right? Next, sodium. Guys, now think how will you do sodium. Try doing sodium. first orbit 2, 2s2, 2p6, right? Now we know that electronic configuration, Rutherford's electronic configuration of sodium, guys, is 281. First orbit can take a maximum of 2 electrons, I've already filled 2. Second orbit can take a maximum of 8, out of which 2 I have filled in s orbital, 6 I have filled in p orbital. I have to move to the third orbit. Right? Third orbital will again start with s orbital. S orbital will take that 1 electron. Electronic configuration is, guys, 281. Right? So first orbit, first you find out the orbit number and then go on filling in the orbitals. Right? Next, magnesium. Yes.
So why we are not taking that 2p7 also?
Because p orbital can take a maximum of 6 electrons.
Not more than.
P orbital has a maximum capacity of 6 electrons. Right? Next, let's move on ahead, guys. Magnesium. Done. Everyone's done magnesium. 1s2, 2s2, 2p6. Now, the third orbital can take a maximum of 2 electrons. Both the electrons will go in the s orbital. So this will be 1s2, 2s2, 2p6, 3s2. Then you have, after magnesium, let's consider aluminium. One s2, 2s2, 2p6. Now the third orbital has to have 3 electrons, out of which 2 will go in s orbital and 1 will go in p orbital. Right? So 3s2, 3p1. S orbital can take a maximum of 2 electrons, so 2 will go there and that 1 extra will go in the p orbital. Right? Next, let's consider silicon. Guys, try doing silicon, please. 1s2, 2s2, 2p6, 3s2, 3p2. Third orbit can have 4 electrons, out of which 2 will be in the s orbital and 2 will be in the p orbital. Phosphorus. One s2, 2s2, 2p6, 3s2, 3p3. Next, after phosphorus, let's consider sulfur. Guys, try the electron configuration for sulfur. 1s2, 2s2, 2p6, 3s2, 3p4. Because the third orbital can have a maximum of 6 electrons. The third orbit has 6 electrons, out of which 2 will go in the s orbital and 4 will go in the p orbital. Right? Chlorine. Electronic configuration is 287. First orbit will take 2. Second orbit will take 8. Third orbit will take 7, out of which 2 will go in s orbital. So the remaining 5 have to go in p orbital. Argon. One s2, 2s2, 2p6, 3s2, 3p6. Electronic configuration is 288. First orbit will take 2 electrons, second orbit will take 8, third orbit has to take 8, out of which 2 will go in s orbital and 6 will go in p orbital. Now starts the fun. Potassium. Someone please do the electronic configuration of potassium. 19. Now the Rutherford's electronic configuration of potassium is 2881. 2881. Now think how you will write it there. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Right? Next, calcium. Let's see calcium, guys. Someone please write the electronic configuration for calcium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now, someone write the electronic configuration of scandium. All of you please try doing this. Think very carefully, guys. Done? Everyone's tried? I'll write the answer. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. How 3D? Guys, let's get back to our Apgo's principle. Can we come back to Apgo's principle? Remember Apgo's principle? Remember while doing that electronic configuration, keep the Apgo's principle in front of you. After 4s, you will not have 4p. After 4s, you have to have 3d. Remember? So you have to make, see, initial first few orbits are very simple. But then later you have to use the Apgo's principle properly. Right? So after 4s, it is not the 4p orbital that will get filled, but it is 3d orbital that will get filled. So that is the reason why I did not write 4p1, but I wrote 3d1. Do you understand why 3d1? Right, now let's move on ahead. We did scandium. Let's see titanium. Now remember, d orbital can take a maximum of 10 electrons. S is 2, P is 6, D is 10, F is 14. Please write the electronic configuration, guys. So it will be, after 4s, it has to be 3d. Now till the time 3d does not get filled, you cannot move ahead. And d orbital will get filled only if there are 10 electrons in d orbital. Right? Let's see the next one. Vanadium. Someone please find out the electron configuration for vanadium. Guys are right. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. Next, try this. This is nice. Chromium. Try writing the electronic configuration of chromium, guys. Alright, now observe very carefully, guys. 1s2, 2s2, 2p6, 3s2, 3p6 is simple. Now after this, ideally it should have been 4s2 and 3d4. But in the case of chromium, does not follow the rule. It is a transition element, it has variable valency. Since it has variable valency, this will not be 4s2 but this will be 4s1 and 3d5. So this one you will have to remember. So chromium will be 4s1 and 3d5. Fine, did we get this thing clear? Next, manganese. Write the electronic configuration of manganese, please. One S2, 2S2, 2P6, 3S2, 3P6. This is very simple. Right? Now, this will become 4S2 and then 3D5. So this will be 4s2 and 3d5. Then Fe, iron. Write the electron configuration of iron, please. One S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D6. Right? After iron, then you have cobalt. Cobalt, please write the electronic configuration of cobalt. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. D orbital can have a maximum of 10 electrons. Nickel. Write the electronic configuration of nickel. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Now this is generally asked in the paper copper. Try writing copper, guys. 1s2, 2s2, 2p6, 3s2, 3p6. Now, this is again like chromium. Variable valency. So this is going to be 4s1 and 3d10. Copper is going to be 4s1 and 3d10. Zinc, right? Zinc is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Right? Do we get this thing here? Now I'm going to give you randomly. We've done first 30, now I'm going to randomly give you some elements and I want you all to write its electronic configuration. Fine? Let's see this. Let's I've also given you that see if you can find some sums based on this. Now you have electronic configuration. I've already taught you. Appliance principle. First 30 elements also I've taught you. You don't have some sums here. Now I'll just tell you the value of Lm for various subshells, right? Now, I think we've done this also. Spin quantum number, azimuthal quantum number, I think we finished everything. All the topics we finished. Let's pick up elements at random and give you. Suppose if I were to give you, say, barium 56, atomic number is 56. Please try writing the electronic configuration of this. Please try writing the electronic configuration of this. Right? If I were to classify this on the basis of Rutherford's model, its electronic configuration would have been 2, 8, 18, 18, 8, 2. Right? So let's try seeing this. 1s2, 2s2, 2p6. So 8 electrons of the second orbital 1. Then you have 3s2, 3p6. Right? Now, before the 3d orbital, 4s orbital has to get filled. So this is going to be 4s2, 3d10. Right? So that means I have 18 electrons now in the third orbital and 2. Now after 4s, 3d. After 3d you have 4p. So you have 4p6. After 4p, you are going to have 5s. Right? Count the number of electrons. 2, 4 and 6, 8. 8 into 10, 12. 12 and 6, 18. 18, 20, 30, 36, 38 electrons you've already finished filling. Right? After 5s, you will have 4d. Right? 36. 4d10. Right? Do we get this? So 36 and 10, 46 is gone. After 4D, you
Or D is like 14.
SPD, D is 10,
Yeah.
F is 14, huh? Right? Now after that you have 5P. After 4D, you have 5P. 6. See how many electrons are gone? This is 10, 18, 20, 30, 36, 46, 46, 48, 49, 50, 54. 54 and I need another 2. That is going to be 6s2. That's how at random you can make electronic configuration of anything. Generally, I would advise you to draw the Apgo's diagram before doing the electronic configuration. If you have this diagram, then you will exactly know what will get filled first. That is going to be my electronic configuration. I'll give you another element, guys. Let's consider, say, let's consider bromine. Atomic number 35 should be simple. Try, guys. Let's start. I'll do 1s2, 2s2, 2p6. First two orbits are very simple to fill. 3s2, 3p6 is also gone. Right? After 3p6, you have 4s2. Right? Then you have 3d10. So now how many electrons are gone? 6, 8, 10, 10, 12, 18, 18, 20, 30. I need another 5. After 3D, you have 4. 4, 3, 5. Right? So do you understand how to write the electronic configuration in orbital order? Right? Do you understand this? Should be very simple. All you need to know is make sure that you know how to write the Apgo's principle. You want me to teach you how to draw this diagram again? Everyone's understood? Right? 1s, 2s, 3s, 4s, 5s, 6s, then 2p to 6p, 3d to 6d, 4f to 6f. And then just draw the lines diagonally. You should get your Apgo's principle then. Fine, do we get this thing there? Do we understand this? Okay. We'll stop this here for the day. Thank you very much.